In 7.2, we're going to learn the law of sines and the law of cosines. So today we're going to focus on the law of sines. So this is a way that I can solve for missing sides and angles within a non-right triangle. So those are called oblique triangles. So if I have a triangle that does not have a right angle, I can use the law of sines, which is derived from the right triangle trigonometry that we used in section 6.1 to create an equation that I can use for any triangle. So a non-right triangle or a right triangle, actually. So if I have a triangle, we'll call it ABC, I'm going to draw an altitude, which is the height of the triangle from C to side C. So I'm going to draw in a little height here. Altitude means that this is a right angle. So notice that I'm creating two right triangles. So I have now a right triangle here. And then I have another right triangle here. Okay, so I have two right triangles now in this diagram. I'm going to write the sine function for each angles A and B and solve for X. Okay, so if I think about angle A, so if angle A is over here, this would be the opposite side of A. So X would be my opposite side. And if I think about the right triangle, B would be my hypotenuse. Okay, so then this piece of C, right, not C, would be the adjacent side if I'm looking at in reference to A. So they want me to write the sine function for angle A and B. Okay, so if my sine of A then, notice, is equal to O over H, so it's equal to X over B. And they want me to solve this for X. So if I need to solve for X, that would mean that I would need to multiply both sides by B. So that tells me that B times sine of A is equal to X. Okay, so they asked me to solve for X for that one. I'm going to do the same thing with angle B. So if I look at angle B and I'm trying to write sine of B, notice that X is still opposite angle B. So O over H, my hypotenuse this time across from my right angle is side A. Okay, so O over H for angle B is X over A. We want to solve for X again. So this time we have to multiply by A. So we get that A times sine of B is equal to X. Okay, so since I have two statements that are both equal to X, they want us to set them equal to each other. So they're both equal to X. So I'm going to take and I'm going to set B times sine of A must then be equal to A times sine of B. Okay, so B times sine of A is equal to A times sine of B. The next step, well, the last step is asking us to divide both sides of the equation by AB. So I'm just going to take and rewrite my equation over here. So I have B sine A is equal to A sine B. And they want me to divide both of them by AB. So I'm going to take and divide both sides by AB. So if I'm dividing by A times B, I can reduce them separately. So this one, the B goes away. And on this one, the A goes away, right? So I can reduce those so that I'm left with sine A over A is equal to sine B over B. And so this tells us that the ratio of the sine of an angle to its opposite side is the same for all angles in the same triangle. So since there's a third side C and a third angle C, we're able to add that on. So every angle, the sine of every angle in a given triangle, so sine of A, sine of B, and sine of C is equal to the ratio of sine of the angle over the opposite side, so the same letter but lowercase, is equal for all angles and sides within the same triangle. So that means that sine of A over A is equal to sine over B is equal to sine over C will be how we will use and set up problems when I have something that is not a right triangle. Okay, so these are essentially the formulas we're going to use for the entirety of these notes. So we have non-right triangles, so we cannot just use SOHCAHTOA. So let's try. So if I have a triangle PQR with the indicated angle measure. So let's draw out triangle PQR. And again, I just know it's not right. I could draw it right if I really wanted to. But I could draw the same triangle every time if I wanted. Okay, so the measure of angle P is 33 degrees. So the measure angle P is 33 degrees. The measure of angle R is 64 degrees. QR, so if we look at our diagram, QR is this one. That's actually the lowercase p. Okay, so QR is 8 centimeters. Again, that's lowercase p is 8 centimeters. They want us to find PR. So PR is opposite Q. Okay, so this is Q. So we're looking for lowercase q to solve. So since we know side P and angle P, so we know an angle and a side that are across from each other, we know the measure of angle P and we know side P. That tells us that, and we want to use sine of P over P because we know both of them. And because we want Q, we want lowercase q, we have to also know sine of Q over Q. Okay. So if we look at what we can plug in, we know measure of angle P. So we know that this is going to be sine of 33 degrees. Over side P was 8 centimeters. I'm going to leave out the centimeters for now. And that is equal to sine of angle Q. Notice we don't know angle Q, and we definitely don't know side Q because that's what we're looking for. So what we need to do is we need to find the measure of angle Q in order to solve the problem. Okay, so we need the measure of angle Q first before we can move on. And so remember that all the angles in a triangle must add to 180. So we're going to take 180 degrees and we're going to subtract the two angles that we know. So that means that we're going to subtract 33 and we're going to subtract 64. So that means that for measure of angle Q, we get 83 degrees. Okay, so we just found that angle Q is 83 degrees in order to make that a triangle. So what we're going to do to solve is we're always going to cross multiply. So if I cross multiply, I'm going to take and I'm going to multiply Q times sine of 33. And I'm going to set that equal to, I'm going to multiply 8 times sine of 83. Okay, so I always need to cross multiply to get rid of the fraction. And then I want Q isolated, so that means that I'm going to need to divide both sides by sine of 33 to get Q by itself. Okay, so what this tells us then is that Q is equal to 8 times sine of 83 divided by sine of 33. I'm going to calculate this and round to the nearest tenth. Okay, so I'm approximating now. So I'm going to type that into the calculator. Remember that on Desmos, sometimes it's easy to make it a fraction when you know it's going to be. So we're going to type 8 sine of 83, close the parenthesis, move to the bottom, divided by sine of 33. Remember, I can type the word sine, see how it straightens out. I know that it knows what I'm talking about. I also don't necessarily need the parentheses. So remember, double check we're in degree mode. And so we get a 14.57. So we're going to round that up to 14.6. So that means that Q is 14.6 and our units were centimeters. Okay, so that is using the law of sines to solve for a missing side of a triangle that is not necessarily right, meaning having a right angle. Let's look at another example. In this one, we're looking for an angle. So in triangle ABC, we have that measure of angle C is 75 degrees. So let's draw out triangle ABC. Notice that I always start on the bottom left and go clockwise. It doesn't matter though. So measure of angle C is 75 degrees. So we've got 75 degrees here. B is equal to 4. So the side opposite B is B, that's 4. And then C is 5. So opposite C, C equals 5. Right, if I was looking for A would be over here. They want us to find the measure of angle B. So we're looking for this. Okay, so remember that because I know everything about C. So I know angle C and side C. I'm going to use sine of C over C. And then because I want B and no B. Okay, so I want to find the angle B. I know the side B. I'm going to use sine of angle B over side B as well. Okay, so let's plug in. So sine of C is 75 degrees. So sine of 75 degrees over 5 is equal to, my unknown is this angle, so sine of B over side B is 4. So to solve again, we're going to cross multiply. So if I cross multiply 5 times sine of B is equal to 4 times sine of 75. So I would divide both sides by 5 to isolate sine of B. So that gives me that sine of B is equal to this. I'm going to calculate. So if we check that out, we've got 4 sine 75 divided by 5. So 4 times sine of 75 divided by 5 gives me this decimal. So because it's a decimal, I'm going to do 4 spaces. So that ends in a 4, so it's going to stay. So 0.7727. 0.7727 is the approximation of sine of B. Remember, this means, and I'm going to move over here, that the measure of angle B is equal to the inverse sine function of that decimal, so of 0.7727. Okay, so let's evaluate that in the calculator. So we need our function inverse sine of that answer, 0.7727, gives us 50.59. So that's going to round up to 50.6 degrees. So again, that was a calculator. So the measure of angle B is approximately 50.6 degrees. So both of these two examples, we were only trying to find one side or one angle. And so we looked for which one do we know both, the side and the angle for, and we started our formula with that. And then we wrote the one that we needed next. So for this one, we knew everything about side C and angle C. We wanted to know angle B, and so we needed to use that. In C, notice that it wants us to find all missing angles and sides. So remember what we did with right triangles, where we wrote out everything together. So if my triangle is named ABC, they're telling me measure of angle A is 35 degrees. I don't know the measure of angle B, so that's going to be an answer. And then they told us that measure of angle C is 62 degrees. And then for the sides, we have side A, side B, side C. Okay, so let's try this one without necessarily drawing out the triangle. So they also told us side C was 7 inches. Okay, so we're gonna solve for side B and for side A. Right? And again, I know they're all inches because if one of them is inches, the rest are too. Okay, so what I want to think about is, so here, since I know both, I'm going to use sine of C over C to solve for whatever I need to solve for. Okay, so to solve for both side A and side B. Okay, so I need to solve for side A, angle B, and side B. Okay, so right now, because I know angle A, I'm gonna set up sine C over C is equal to sine A over A, and that's gonna help me solve for side A, okay, because I know most of these, right? So I know measure of angle C is 62 degrees, so let's plug that in. So we've got sine of 62 over 7. is equal to sine of 35 over A. So if we cross multiply, A times sine of 62 is equal to 7 times sine of 35. So to get A by itself, we would need to divide both sides by sine of 62. So that tells us that A is going to be approximately 7 times sine of 35 over sine of 62. So let's calculate 7 times sine of 35 over sine of 62. Okay, so that means that side A, if I round 4.54, that's going to just round to 4.5. So A is approximately 4.5. So we've got our first answer that A is 4.5 inches. Okay, so I started with sine of C over C because I knew both the angle and the side for that. Technically, I could use A now, but it's not a good idea because I've just rounded it. Okay, so to solve for B, I'm still going to use C. However, I need to find the measure angle B first. So if I think about that, I know that in a triangle, all the angles add to 180. So I'm going to take 180 degrees and I'm going to subtract measure of angle A is 35 and measure of angle B is 62. And so if I do 180 minus 35 minus 62, that's going to give me 83 degrees. Okay, so I've just found my second answer. Measure of angle B is 83 degrees. And now that I know measure of angle B, I can use it to solve for side B. So again, I'm still going to start with sine C over C because those were given, so they're more accurate. In order to solve for the side B, I now can use the 83 degrees with the sine to find that missing side. Okay, so we can plug in. Again, we're still doing sine of 62 over 7. This time is equal to sine of 83 over our unknown. So if we cross multiply, B times sine of 62 is going to be equal to 7 times sine of 83. Then we're going to solve for B. So let's divide both sides by sine of 62. So B, we're going to calculate 7 times sine of 83 over sine of 62. Notice that we can just change this, right? It was a 35. We're going to change it to an 83. And that's going to give us 7.86. So that's going to round to 7.9. Okay, so side B is 7.9. So our final answer is 7.9 inches for side B. Just like in right triangles, it's good strategy to check. If I have the smallest angle, that should be across from the smallest side. Largest angle, largest side, middle angle, middle side. Okay, so you can use that as a check to make sure that you did things appropriately. Okay, so notice I don't actually have to draw the triangle to be able to see what's across from what if I use that alphabetical correlation in my setup instead. Okay, so I could have drawn the triangle, but I don't need to. Okay, so in example 2, they've given us the diagram of an obstacle course and labeled it with all the information. So let's just kind of read through. and annotate and try to color code. So if I have, of course I used a weird color here. Okay, so Nicholas is walking along an obstacle course that begins at point X. So he's starting here at point X. He starts going straight on the path and he takes a wide right turn at point Y and continues for 1,000 feet. So notice that it is labeled for the first path. He traveled 1,200 feet. That's across from angle Z, so that's technically lowercase z. If I look at the way the diagram is. So he starts. So that's that length of the obstacle course. He then takes a wide right turn onto a second path at point Y and continues for 1,000 feet. Notice that's across from X, which is the 32. So that's our lowercase x. And then he continues down the final path at point Z. They want to know the angle between the second path and the final path at point Z. So they want us to find the measure of angle Z. Is our answer. If we think about what we know, looking at the diagram, we know angle X and side X. So we know that the measure of angle X is 32 degrees. We also know that side X is 1,000 feet. We don't know the measure of angle Z, right? That's what we're looking for. But we do know that its side is 1,200 feet. Okay, so notice that we don't know anything about side Y or angle Y, but it's not necessarily necessary for the problem. We only need to know a pair and then one piece of whatever we need, the opposite of whatever it is we need. Okay, so we can set up then law of sines. So remember that since we know everything about X, we're going to use sine X over X because we know both. And then that's going to be equal to sine Z over Z because we know one. Okay, and that's what we're looking for, right? We're looking for this Z here. So let's substitute in. So angle X is 32 degrees. So sine of 32 degrees over 1,000 is equal to sine of our unknown over 1,200. So I know my answer is going to be bigger than 32 because the side is bigger than 32. If I cross multiply, I'm going to get 1,200 times sine of 32 is equal to 1,000 times sine of Z. So to get Z by itself, I'm going to have to divide by 1,000 first. And that's going to give me sine of Z. Okay, so let's calculate 1,200 times sine of 32 divided by 1,000. So 1,200 times sine of 32 divided by 1,000 gives us 0.6359. So 0.6359. So that means that the measure of angle Z is going to be equal to the inverse sine of that value. So the inverse sine of 0.6359 is going to give us the measure of angle Z. 0.6359 gives us 39.5 degrees. So that means that the measure of angle Z is approximately 39.5 degrees. Okay, so their angle if they turn at that final path is 39.5 degrees. Remember, we said that it should be bigger than 32 because 1,200 is bigger than 1,000. So that checks out good. Okay, so remember that with law of sines, we are given 3 equations or 3 pieces to an equation to use to set up. We only ever use 2 pieces. One of the pieces we know both parts to. The other piece is what we want, so we need to know one of those 2 pieces. Okay, we still know that angles inside of a triangle add up to 180, and so we might need to use that to solve for something first.